So here we're looking at properties of functions, and we have a definition. We're going to define what it means for x comma y to be a point on the graph of a function f. So let's say you got a function f. X comma y is a point on the graph of that function f, provided f of x equals y. That means when you plug x into the function, you get the out point of exactly y. So do maybe an example of that. Example. So let's say we have a function that's given to us. Let f of x be the function given by 6x squared plus 11x minus 10. And our instructions are to determine if the point that's given below is on the graph of f. So here's 1. So we're going to look at the point -1, -15. Excuse me. So what we're going to do, we're going to take -1 and we're going to plug it into our function f. So here goes. I'm going to take f and evaluate it -1. So when I plug in -1 into the function, that means I'm going to, first of all, write a template with some blanks. 6 blank squared plus 11 times blank minus 10. Okay, those blanks are where the x's were. Now, instead of putting those x's, I'm going to put -1s for my x's. -1 and -1 for the x's. So you have to perform these operations. So rather than multiplying 6 times -1, you have to do exponentiation first, right? Please excuse my dear Aunt Sally. So exponents come before multiplication. So rather than doing 6 times -1, we're going to do -1 squared. So I'm going to leave the 6 times alone. We're going to do -1 squared. What's -1 squared? Well, -1 squared is -1 times -1. So 1. And we got, okay, so we got 6 times 1. I'm going to do 1 times -1. 1 times 11. 11 times -1. 11 times -1 is -11. Don't forget we have a minus 10. So I got f at -1 equals, okay, let's do this multiplication. 6 times 1 is 6 plus, okay, I'm going to do this here. -11 combined with -10, that's -21. So finally I'm going to find what f at -1 is by combining, let's see, 6 plus -21. What's 6 plus -21? 6 plus -21 is -15. So the question is, does our y value, that's our y value right there, -15 in yellow, does that match with this? Yes. So we're going to say yes, -1, -15 is a point on f. On the function f. Since when you plug in -1, you get out -15. F of -1 is -15. Okay? Now you want to show your work and you want to write a little statement there describing why it's the case. Number 2, let's look at another point, 2, 30. The question is 2, 30 a point on the graph of this function f? Well, let's check. We're going to plug in 2 into the function and see if we get an output of 30 out here. Well, let's see. Here goes. F of 2. So I'm going to make up a template. It's going to be 6 times a blank squared plus 11 times a blank minus 10. I'm going to plug in 2 for my x's. So what f of 2 is exactly, let's see. Should be a red 2, right? So when you're doing order of operations, remember exponents come first. So we're going to do 6 times, let's see, 2 squared. 2 squared is 2 times 2 is 4. So we got 6 times 4 plus 11 times 2 is 22, and then minus 10. It's going to give me f of 2 is equal to, let's see, 6 times 4 is 24, plus, let's see, I combine these right here, 22 minus 10. 22 minus 10 is 12. Okay, so 24 plus 12 is what we actually have. We got f of 2 is equal to 36. So our y value is 36. Does that match with the y value from the point? No. So 2 comma 30, it's a point, but it's not on the graph of f. So no, we're going to respond that no, 2 comma 30 is not a point on f. It's a point, but it's not on the function f. On f. Since f of 2 does not equal 30. Right, f of 2 does not equal to 30. We wanted it to be equal to 30, but it's not. It's equal to 36. Okay. Okay, so we've already looked a little bit at x-intercepts. We know how to find x-intercepts. Remember, to find x-intercepts, you set the y value equal to 0 and solve for x. So let's take this same function we're looking at. This function is 6x squared plus 11x minus 10. Let's find the x-intercepts of this function. Okay? So what we do, remember we set the y value equal to 0. Remember, the y value for a function is the f of x value. So we're going to set the f of x value equal to 0. So remember, f of x was 6x squared plus 11x minus 10. So here we go, 6x squared plus 11x minus 10. And we're going to set that equal to 0. Okay, so there are a couple of ways to solve this equation. Now notice this is a quadratic. This is a quadratic equation, right? What's a quadratic equation? It's an equation where the largest power is a power of 2. Now typically with a quadratic equation, you want to get 0 on one side, everything else on the other side. So we have that. That's right, the general form for a quadratic where you have 0 on one side, everything else on the other side. Now there are a couple of ways you can solve this. One is factoring. So I'm going to use factoring. The second way you could solve this is quadratic formula, which I'll use the quadratic formula later as a second method. But first I'm going to do factoring. So to do factoring, what I'm going to do, I'm going to make 2 pairs of parentheses. And you're going to have 2 things that multiply together to give you 6x squared plus 11x minus 10. And all that's equal to 0. So I'm going to put equals 0 on this side. Now in order to factor here, I'm going to use a technique known as magic factor. I'm going to find 2 numbers. Now, first of all, multiply to give this first number times this last number here, 6 times negative 10. What is 6 times negative 10? Well, 6 times negative 10 is negative 60. I'm going to find 2 numbers that multiply to give negative 60 and add to give this middle number right here, which is positive 11. So if you can find 2 numbers that multiply to give you 6 times negative 10, negative 60, and add to give you the middle number, positive 11, then you're in good shape. If you think about that long enough, you'll come up with 2 numbers of 15 and minus 4. 15 and minus 4 multiply to give you negative 60, and they add 15 and negative 4 add to give you positive 11. So what we're going to do, we're going to write down here for our factors, we're going to write down first of all a 6x, and here a 6x. And then we're going to take those 2 numbers that we found, we're going to take positive 15 and negative 4, and we're going to write positive 15 here after the first 6x, and then a minus 4 after the second 6x. Now I'm not done with my factoring. I have to make sure I divide out anything in common within the first pair of the factors, and then anything in common within the second pair of the factors. So I'm going to look at 6x here and 15. I'm going to ask myself, okay, is there anything in common between 6x and 15 that can be divided out? Yeah, 3, right? 6 and 15 have a 3 in common. So we're going to divide 3 out of the 6 and 3 out of the 15. And when we do that, we're going to say, okay, 6 divided by 3 is 2, so we're going to have 2 with an x. Plus, and then 15 divided by 3 is 5, so I'm going to have 2x plus 5. That's for my first factor. Now for my second factor, notice I have 6x minus 4. 6x minus 4. Is there anything in common between 6 and 4 that we can divide out? Well, yeah. 6 and 4 are both divisible by 2, so I'm going to divide a 2 out of the 6x and a 2 out of the 4. So for my second factor, when I do 6 divided by 2, that gives me 3 with an x, and then minus 4 divided by 2 is 2. So 3x minus 2 is my second factor. This is equal to 0. Now anytime you have two factors multiplied to give you 0, one of those factors has to necessarily be 0. So either 2x plus 5 is 0, or 3x minus 2 is 0. So what we've done, we've basically reduced this. We've reduced this quadratic equation to two simple linear equations. The first one we can subtract 5 from both sides. The second equation we could actually add 2 to both sides. So for the first equation we're going to have 2x equals negative 5, and for the second equation we're going to have 3x equals 2. Okay, going back to the first equation, we have 2x equals negative 5. We have to get rid of the multiplication by 2, so we're going to divide both sides by 2, in which case the 2's cancel on the left side, and we're going to get x equals minus 5 halves. For the second equation, you have 3x equals 2. You want to eliminate the multiplication by 3, so you're going to divide both sides by 3, and the 3's will cancel, and you get x equals 2/3. So your two solutions here, your two x-intercepts are negative 5/3 and positive 2/3. So that means the graph of your function is going to hit the x-axis at negative 5 halves, or you could say negative 2.5. And it's going to also hit the x-axis at positive 2/3. So this is the factoring technique for solving this quadratic equation. Now the other technique we could use is called the quadratic formula. So alternatively, you can use the quadratic formula. And maybe you remember the quadratic formula from high school. It goes something like the solutions x are of the form minus b plus or minus the square root, b squared minus 4ac, all divided by 2a. So remember what your b is. Your b is the coefficient in front of the x term. So b is going to be here 11. So b is positive 11. A is going to be the coefficient in front of the x squared term. So a is going to be 6. And then c, we'll make that orange. It's going to be the constant here, negative 10. So we'll plug all those values into the quadratic formula, where we'll have minus 11 plus or minus the square root of blank squared minus 4 times blank, all over 2 times blank. I'm basically making a template. So for B, we said we had 11. Let's plug in 11 there. For A, we had 6. Get a purple color for that. We're going to 6 for A here, 6 for A here. And for C, orange, we had negative 10. So the negative 10 goes in right here. When I simplify this, I get minus 11 plus or minus the square root of, let's do 11 squared. You want to do this 11 squared here. 11 squared is 121. And then you're going to have all of this here multiplied together. Put that in another black box. So if I take negative 4 times 6 times negative 10, negative 4 times 6 is negative 24. Negative 24 times negative 10 is positive 240. So I'm going to add, right, because we get a positive. Negative 4 times 6 is negative 24. Negative 24 times negative 10 is positive 240. So that's a plus 240. All right, and all that's going to be divided by 6 times 2, or 2 times 6 is 12. Now that's going to be negative 11 plus or minus the square root of, if you take the black numbers, 121 plus 240, you're going to get 361, all divided by 12. So I'm simplifying. I'm going to take the square root of 361. The square root of 361 right here, that's 19. So you got a negative 11 plus or minus 19 over 12. And this basically breaks into two solutions. So we'll get, let's see, negative 11 plus 19 over 12, and negative 11 minus 19 over 12. So in the plus case, we're going to do what? Negative 11 plus 19 is 8. So we have 8 over 12. 8 over 12, if you divide 4 out of the top, and divide 4 out of the bottom, reducing that fraction. 8 divided by 4 on top is 2. 12 divided by 4 on bottom is 3. You get 2/3. In the other instance, you get, let's see, negative 11 minus 19. Negative 11 minus 19 is negative 30 over 12. So you can divide a, let's see, what can you divide out of negative 30 and 12? I believe you can divide out a 6 out of the top and a 6 out of the bottom. So if I take negative 30 divided by 6, I get negative 5, and on bottom 12 divided by 6 is 2, negative 5/2. So here I have my two x-intercepts. 2/3 or negative 5/2. Either of those are x-intercepts. So earlier we had that as well, right? We had 2/3 and negative 5/2. Different ways to get it. Personally, I like factoring. Factoring's quicker for me. But if you don't like factoring, if you're not a great factor, you can use a quadratic formula, which is a little more tedious. Okay, so in any case, you get negative 5/2 and 2/3 for your two x-intercepts. That's where the graph hits the x-axis. Okay, let's also do a y-intercept. Determine the y-intercepts of the function. Now maybe you remember that to find y-intercepts, where the graph is going to hit the y-axis, you're going to set the x value equal to 0. So we're going to set x equal to 0. So I'm going to go back to my function, and I'm going to plug 0 in for x. So what was my function? Remember, my function was f of x equals 6x squared plus 11x minus 10, right? This was my function. So everywhere I have an x, I'm going to plug in a 0. So let's do that. We're going to find what f of 0 is, basically. So f of 0 is what we're doing. We're plugging in 0 for x. It's going to give us a 6 times a blank squared plus 11 times a blank minus 10. And everywhere I have a blank, everywhere I had an x, I'm going to put a 0. Now, this is nice. I love plugging in 0. It's my favorite thing. Makes life easy. So we're going to have what? 6 times 0 squared is 0, plus 11 times 0 is 0, minus 10. That means f of 0 is going to be, let's see, 6 times 0 is 0, plus 0, minus 10. In other words, negative 10. F of 0 is negative 10. So you can say your y-intercept is y equals 10. Oh, sorry, negative 10. I didn't write that correctly. Negative 10. So when the x value is 0, the y value is negative 10. So that means your graph hits the y-axis at negative 10. Negative 10 on the y-axis. Okay, do a little more maybe. Do one more thing with this same function. So using the same function, determine the x values. So for which x values does this function achieve a y value of negative 10? In other words, determine the x values for which f of x equals negative 10. So f of x is the y value. So when is the y value negative 10? That's what we're asking. When is the y value negative 10? For which x value? So what I'm going to do, I'm going to take my function. I'm going to set it equal to negative 10. Okay, so let's see. What was our function? It was 6x squared plus 11x minus 10. So that was our function. So we're setting that equal to negative 10. So to solve this equation, this is a quadratic equation. What's a quadratic equation? It's an equation when you have your largest power of 2. So basically a square in your equation. So to solve this, typically with a quadratic, you want to get 0 on one side. So if I want to get 0 on the right-hand side, I'm going to add 10 to both sides. I don't want that negative 10 there. I want to get rid of it, so I'm going to add 10. So that's going to give me, let's see, 6x squared plus 11x. Okay, minus 10 and plus 10 cancel on the left, and on the right, minus 10 and plus 10 cancel. So I get 0 here on the right. Now, this is a quadratic, but it's a binomial. There are only 2 terms. They're not 3 terms. So if I wanted to factor this, I could say, okay, what's in common here between 6x squared and 11x? Well, there's an x in common, right? We can pull out an x. So I'm going to pull out an x. And then I'm going to put a pair of parentheses. I'm going to ask the question, when I pull out an x, what's left in parentheses? In other words, what times x gives me 6x squared? 6x. Okay, then I'm going to put a plus sign. And then I'm going to ask the question, what times that x gives me 11x? Well, positive 11. Right? 6x times x gives me 6x squared, and positive 11 times x gives me 11x. This is all equal to 0 when these two things are multiplied together. Now, by the zero product property, if I have something times something equal to 0, then one of those things has to be 0. So either x is 0, or 6x plus 11 is equal to 0. So we have one of our solutions already in red. That's x equals 0. That's one of our solutions. The other solution we're going to get by solving 6x plus 11 equals 0 for x. So to solve that for x, we're going to subtract 11 from both sides. And we're going to get 6x equals minus 11. And then we're just going to divide both sides by 6 here to get rid of the 6. And we'll get x equals minus 11 over 6. So when is the y value equal to negative 10? When the x value is 0, and when the x value is negative 11 over 6. All right. So I think that's going to be it for this video.